Yeah, notes out. Take out your notes. Um, I hope people actually like come to this. I just sent out the email. I don't know, it's really close to dinner, and but whatever. That's fine. I'll try and start this at 5:50, so about 5 minutes from now. All right. Sorry this is late. Hi, Will. Um, I don't know what to listen to. Tell me what to listen to. I'm not listening to Pink Floyd. That's no. I need viewer interactions to get donations. Don't hate. I'm not hating on Pink Floyd. I just don't want to listen to Pink Floyd. Let's run it. You got Chick-fil-A. Wait, you can eat while watching it. That's okay. All right. Anyway, so it's 5:50, so we'll get started. I'm not gonna do the condensed notes thing. Um, the calc review took longer than I thought it would, and I ended up screwing that up because I sent an email out to just myself when I meant to reply all. Anyway, so I'm gonna go through this step by step, and I'll kind of do a rundown of the test first. Number 1 and 2 should be the easiest questions that you do on this test. Period. Okay. Number 1 has to do with the distance formula. You have to verify whether or not the distance is between these 3 points. Give us the vertices of a right triangle. Okay, so you're doing the distance formula 3 times over. You're plugging that into Pythagorean theorem. You're seeing if it holds true. If it does, you have a right triangle. If it doesn't, you don't. Okay. Number 2, you're given 2 points. So this is going back to algebra 1, if not before. You're given 2 points. You need to find the slope. You need to find the equation of a line either in y equals mx plus b or y minus y1 is equal to m times x minus x1. If I'm going way too fast, it's okay. I'm going to go through this as we go. Number 3, 4, 5, and 6 has to do with transformations. Okay, so I'm asking you to draw a picture of the graph. This should be really easy because you have a calculator, but what I want you to do on top of this is to identify the transformations, right? So looking at like number 3, you should be able to understand that it's shifted left 3 units and upside down. That's part of the problem. Okay. So that's the same for 3, 4, 5, and 6. Number 7, sketch the graph of the following. Show all work. You're using the leading coefficient test, the rational zero test, the polynomial division, and intermediate value theorem. So you're finding the zeros, you're testing between them, you're using the leading coefficient test, all that stuff. This is the exact same type of question that was on the last test. Okay. Number 8, given factors, write the complete factorization of the polynomial, right? So you're going to use some kind of polynomial division. 9, 10, and 9 and 10. Okay. So first, before I forget, and so I can see this or hear this later from you as well, I accidentally put 3 of these on the test, and I only meant to put 2. So I'm going to, I think I'm getting rid of number 9 on the test that I'm going to give you tomorrow. So the very first asymptote question on the test, I'm getting rid of it. This means nothing to you. I'm just saying this so I remember it. But anyway, 9 and 10. For each function, identify the holes, the vertical asymptotes, the horizontal or slant asymptotes, and then sketch the graph. Okay, so that's numbers 9 and 10. 11 through 15. Again, I think I had one more on here than the actual test that I printed because I forgot to look at this first. So I know exactly which one. I think it's, I have to go back and look at it. But you're solving logarithms, okay? And then number 16 and 17 are exactly the same that I have on here, okay? I am not going to do number 16 and 17 for you on this. I'm leaving that up to you. And this is a problem where I am going to actually ask you to show work. Okay. I know I didn't on the last time I did this, but I am asking you to show work on this case. All right. So that's the entire test in a nutshell. There's only a couple really long problems. 9 and 10 are kind of long, kind of not. 8, kind of long, kind of not. 7, I think, is going to take the longest time. Everything else should be really straightforward. All right. So let's go through this. Again, as you have questions, ask. There's about a 10-second delay, so I'll pause kind of after every problem. And if you have questions, ask, and I can try and explain it. All right. If you cannot understand something I just wrote or didn't understand something I just said, just say so, and I'll explain it. So Number one, prove whether or not the following points are vertices of a right triangle. Okay, so we need to find the distance between x1, y1, x2, y2, and x3, y3. All right, so I'm going to label these in different colors and different points, so in different subscripts rather, so we see which one is which. All right, so D1, I'm going to say is the distance between x1, y1, and x2, y2. That's going to be the square root. And I guess I can write this up top. Distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so x2 is 3. x1 is also 3. y2 is 12. y1 is 7. I'm just going to leave it like that for a second. I'm going to write everything out first. The second distance, that's going to be the distance between x1, y1, and x3, y3. So we have the square root. Y3 is 12 minus y1, 7. x3 is also 12. x1 is 3. I wrote that wrong. No, I wrote that right. Why did I? Oh, I did x1. Okay. Just, it doesn't matter which order, as long as you're consistent. And then we do the same thing between x2 and x3. All right, so x3 is 12. x2 is 3. y3 is 12. y2 is 12. Okay, so D1, 3 minus 3 is 0. 0 squared is also 0. 12 minus 7 is 5. 5 squared is 25. D2, 12 minus 7 is 5. 5 squared is 25. 12 minus 3 is 9. 9 squared is 81. Twelve minus 3 is 9. 9 squared is 81. 12 minus 12 is 0, so we just get 81. And you don't even have to square these, because when you square a square root, they're going to go anyway. They're going to go away anyway. So I'm just going to leave them. I'm just going to clean up 25 plus 81. 25 plus 81 is 106. Okay. Our job is to plug this into Pythagorean theorem and see if it works, right? So the biggest is always C. So these other two can be A and B. C has to be the biggest one. Right, so we need to see if the square root of 25 squared plus the square root of 81 squared is equal to the square root of 106 squared. So when we do that, we get 25 plus 81. We need to see if that equals 106. It does. That means this is a right triangle. Okay, I believe that was worth 9 points. I think I'm giving 1 point for just knowing the equation, 1 point for each distance. That's 4. Somehow including the Pythagorean theorem, that's 5. Maybe it's 2 points for the equation. I think it's 2 points for the equation. 2, 3, 4, 5, 6. And then an answer is 2 points. Might be worth 7. I think it's worth 7. Anyway, that's how you do it. Number 2, write the equation of the line between the following points. So whenever we have 2 points and we're finding the equation of a line, we have to find the slope. Slope is the difference of y2 minus y1, so 5/3 minus -5 over x2 minus x1, so 1/2 minus 4. 5/3 minus 5. So we get 5/3 plus 15 over 3. 1/2 minus 4, so that's 1/2 minus 8/2. So that's 20/3 divided by 7/2, which is 40 over 21. So that's our slope. And then we can go one of 2 different ways. We can use y equals mx plus b, or y minus y1 is equal to m times x minus x1. I always like point slope form, which is the second one, because it's really easy to deal with. So I'm going to do that. So if we do that, I'm going to pick x1, y1 as our point. So we have y plus 5 is equal to 40 over 21, x minus 4. And that's an answer. There are different answers, right? We could use x2, y2. We could use slope-intercept form. There's a bunch of different answers. This is the one that I'm going to show you right now because I think this is the easiest, and then we're done. 3, 4, 5, and 6, identify the transformations on the parent function, then sketch the graph of each function. All right, so the first thing we need to do is just identify the transformations, right? So this negative says we're flipping our parent function upside down. Oops. And this plus 3 on the inside, that means we're going left 3. Okay, this is a cubic, so we are left 3. And we are upside down, so our equation, our graph is going to look something like this. Doesn't have to be super exact, I just need to clearly see that you know the orientation and where it's shifted. Might be worth it to point a point there so I know. Okay, number 4, negative on the inside, that means flip direction, so left to right. This plus 3 on the inside means shift left. So you are left 3. It's the square root, and it's going the opposite direction. So that's our graph. Number 5, this is a square root function. First thing, we got to flip it upside down. This minus 2 on the outside, it's not inside, it's outside, means we go down 2. So upside down and down 2. So we're going to look something like that. Again, doesn't have to be super exact, so long as you know the shape of it, I'm fine. Yeah, that's fine. Number 6, this negative out front says, again, upside down. The minus 3 says go down 3. And this is a reciprocal function, so it looks a little bit wonky. Right, we have a vertical and a horizontal asymptote. It's upside down, so the we're going to be up on the left, and we're going to be down on the right. And then that's our graph. Again, doesn't have to be exact. I just need to know you know the orientation. Okay, so that's transformations. Now we get to like probably the longest problem. Sketch the graph of the following function, show all work. You should use the leading coefficient test, the rational zero test, polynomial division, and the intermediate value theorem. So we need to find all the zeros. We need to use the leading coefficient test, and we need to test between the zeros. A good rule of thumb is to plug this into a calculator so you know about what the zeros are, and you know about what the graph is going to look like. What I'm asking you to do is to show your work behind all that stuff. What wording would you use if it was flipped to the side, reflect across the y-axis? That's fine. That's the actual like legit definition of it, is a reflection around the y-axis. I say switch direction. I just need to know what you're talking about. So if you say something like flip direction, I just need to see that it's going this way for this problem, for example. Okay. If you want to use reflected about the y-axis, I would encourage that. That's better language. I'm just not super concerned about it. Okay, so back to this. Leading coefficient test. So I'll do these in different colors. Leading coefficient test says we're going to get our degree. The degree in this case is 4. That's the highest exponent. That is even, which tells us like the overall shape of the graph. Our leading coefficient is the thing out in front of x to the 4th. That's just 1, which is positive. And that tells us what's happening as we go way far left and way far right. So in this case, as we go far left, it's going up. As we go far right, it's also going up. Then we need to find the zeros. So it's kind of like all of this. All right. If you can factor. I will tell you right now, that's not going to happen. So we need some way to find zeros of this thing. Again, ideally, you're looking at a graph on your calculator to help you to get a good idea of what the zeros actually are. And that way you can test those things. But in order to start this, we need to use the rational zero test. The rational zero test says that we're going to take factors of the constant term over factors of the leading coefficient. Okay, possible factors. So the possible factors of that constant term are going to be plus or minus 5 and plus or minus 1. The factors of the leading coefficient are just plus or minus 1. All right, so now our list would be 5 and negative 5 and 1 and negative 1. Okay, and this gives us something to test, right? So we need to plug in f of 5 or f of negative 5 or f of 1 or f of negative 1. Again, ideally you see where the 0 is. I'm actually going to look on the graph right now. And when I look at the graph, I can see that it clearly goes through negative 5. So I'm just going to test negative 5. You could test other things. I also see that it goes through 1, but we're just going to test those just to make sure. So negative 5 to the 4th plus 4 times negative 5 cubed minus 4 times negative 5 squared plus 4 times negative 5 minus 5. When we do that on a calculator. Wait. Okay, so 5 to the 4th. Sorry, I messed something up. So this is 625. Negative 5 cubed, that's negative 125. Negative 125 times 4 is 500, so that's minus 500. Oh, I see. So there should be a 4 here. Minus 20, minus 5. This is equal to 0. Okay, so that verifies that x equals negative 5 is a 0. Therefore, x plus 5 is a factor. And then you could go about this next part in a lot of different ways. I guess I left the directions open so you don't have to find all of the zeros. You just have to find the real zeros. So you could just test positive 1 and then get the answer that way, and then figure out the other zeros and then find the graph. Which I guess we can do, right? So I also said that f equals 1 is a 0. So that'd be 1 plus 4 minus 4 plus 4 minus 5. 4 plus 4 is 8. Plus 1 is 9. So this is also equal to 0. So x equals 1. That's 0, so x minus 1 is a factor. In order to get the rest of the factors, we would multiply x plus 5 times x minus 1. We would get x squared minus x plus 5x minus 5. And what we need to do with this is we need to divide x squared plus 4x minus 5 into our polynomial. So we have x to the 4th plus 4x cubed minus 4x squared plus 4x minus 5. And that'll hopefully give us the rest, right? So in order to do long division, we do x squared into x to the 4th. That goes in x squared times. X squared times x squared is x to the 4th. 4x times x squared is x cubed. Negative 5 times x squared is negative 5x squared. Or subtracting all that stuff. So we get x squared. Bring down the 4x. Bring down the negative 5. That goes in once. And then there's no remainder. So then our other factor is this x squared plus 1. So our complete factorization, which we're going to get to in the next part, is going to be x plus 5, x minus 1 times x squared plus 1. So I might be showing a little bit more work than you need. But this thing is our polynomial. It's just in factored form. Now, there are no other zeros besides negative 5 and 1, because this x squared plus 1, if we set that equal to 0, we're going to get x is equal to plus or minus I, okay? Because we can't graph that, we're not worried about it. Do we have to write out us plugging in the numbers to see if it equals 0? No, you do not. If you just do f of negative 5 is equal to 0, that's fine. I just need to know you plugged it in correctly. Okay, same thing here. Okay, but where was that? So we get x equals plus or minus I. We're not worried about that because it doesn't, we can't plot that on a graph. So we know we have two real zeros, which is great because that's all we should have. Will you take off if we include imaginary numbers? If you include imaginary numbers, no. The problem is you can't graph them on a graph. So no i's, right? This equation does have plus or minus I as a zero, but they're complex and we can't graph complex numbers in our real coordinate system. Okay, so this stuff is just kind of like bonus. You should be able to do that. That should be pretty straightforward. But this is kind of the process that I'm thinking of. Okay, so let's graph this stuff. All right, so we have the zeros. We have x equals -5. We have x equals 1. And those are our two real zeros. All right, there's two other imaginaries. These are the other imaginaries, but again, we can't graph that. That does determine the amount of turns it has, but I'm not really worried about it. Okay. From our end behavior, we know that it's going up in both directions. And we know that because it's positive and even. Now our job is to test in between just to see what the graph looks like. I'll do that in green over here. Okay, so we're going to test a number between -5 and 1. So let's test 0. When we test 0, we're going to get -5. So then our graph is going to come down like this. Okay, again, there's a little bit of stuff that happens in the middle, so this isn't totally exact. I think it comes down like this. But that's what the graph is going to look like. Okay, I hope I didn't confuse you with the extra like i's in there, but it's important just to test and see if there's any other real zeros. So you kind of do have to do that. But from the graph you are putting in a calculator, you should see it. So it shouldn't be like a surprise. And again, this is probably the longest problem on here. The reason it's the longest is because I'm asking you to use that rational zero test in polynomial division just to check if there's other real zeros. So I'm going to wait like 10 seconds and then I'm going to go forward. Okay, I'm assuming there's no questions on it. So I'm going to go forward. Number 8 is very similar to the one that we just did, except it's giving you two factors, right? So number 8 says, given the following factors of f of x, that's these two things right here. I want the complete factorization of f of x. So complete factorization, it's going to look something like this, right? It's going to be a combination of linear terms with quadratic terms without real solutions. All right, so we have two factors. So we know that 2x minus 1 divides this polynomial and x minus 3 divides that polynomial, which means that when we multiply those two things together, it should also divide that polynomial. Okay, so what I'm going to do is I'm going to multiply 2x minus 1 by x minus 3. When we do that, we get 2x squared minus 6x minus x. So we get minus 7x plus 3. Okay, so these two things are factors of that polynomial. Therefore, this thing is a factor of the polynomial, which means it divides evenly into the polynomial that we're given. So what we can do in order to find the rest of the factorization is to divide 2x squared minus 7x plus 3 into that polynomial that I gave you. into f of x. So 2x to the fourth minus 7x cubed plus 11x squared minus 28x plus 12. And then we're just doing polynomial division, and we're going to come across a couple answers, right? So 2x squared into 2x to the fourth, that goes in x squared times 2x squared times x squared, that's 2x to the fourth, which is what we wanted. Negative 7x times x squared is negative 7x cubed. And 3 times x squared, that gives us 3x squared. We're going to subtract those things. So 11 minus 3, that's got 8x squared. Bring down the rest. 2x squared goes into 8x squared 4 times. So 2x squared times 4, that's 8x squared. Negative 7x times 4 is negative 28x. And 3 times 4, that's 12. There's no remainder, which is good. That's exactly what we thought was going to happen. Okay, so now we have this new factor. Okay, so 2x squared minus 7x minus 3, which is what we got from multiplying those two factors, times this thing is going to give us our original polynomial. Okay, so our kind of complete factorization, I'm going to hold off on calling it that for a second, is 2x minus 1, the factor that we're given, x minus 3, the factor that we're given, times x squared plus 4 is the factor that we found. This x squared plus 4 can kind of be split up. You could stop here if you wanted to, but if we really want to get the complete factorization, we would go a step further and solve this. So we'd get x is equal to plus or minus 2i. So we'd get x minus 2i and x plus 2i. So our complete factorization is 2x minus 1, x minus 3, x minus 2i, x plus 2i. Do we need to? No. By the definition of the book, this is actually a complete factorization because any polynomial can be written as a product of linear terms, which are these guys, and quadratic terms without real zeros, which is this guy. So really that's like by the book standards, so by my standards, that's fine. We could split it up into two things though, which is the x minus 2i times x plus 2i. From x squared plus 4, you should really know that already, but that's, again, I'm kind of making it more, I guess. So the stuff that I have highlighted with the arrow next to it, that's fine. So this stuff. So a little bit less than the problem above it. All right, on to the asymptotes. Again, on the test, I think I printed 3 asymptote questions. I'm only meant to give you 2, so I'm going to cross one of those out. And I gave you 6 log questions. I meant to give you 3 or 5, so I'll cross one of those out as well. All right, but regardless, number 9 and 10 say for each function, identify the holes, the vertical asymptotes, and horizontal or slant asymptotes, and then sketch the graph. Okay. So the first thing we should always start to do is we should start to try and find holes if there are any. So we're going to try and factor the top and the bottom. For the top, we can factor out an x to get x plus 1. On the bottom, we could rewrite this as x squared negative x squared minus 9. So we get x times x plus 1 times negative x plus 3, x minus 3. So we can't factor anything out. So there are no holes. Okay, if we could factor something out, that's when there's a hole, and we set that thing that we factored out equal to 0, and that's where the hole is going to be. In this case, we can't, so there's not. Okay, the reason we factor first too is because this helps us find our vertical asymptotes really, really easily. Right, so for vertical asymptotes, we set the denominator equal to 0. The denominator is negative x squared plus 9, which is the same as negative x plus 3 times x minus 3. So we set that equal to 0. We get x equals negative 3 and x equals positive 3. So that's x equals negative 3, x equals positive 3 is right here. And that's the first part done. Okay. Horizontal asymptotes, that's when we're comparing the numerator and denominator. Okay, the numerator degree, that's the highest exponent on the top, that's 2. The denominator degree, that's the highest exponent on bottom, that's also 2. Because these things are equal, we want to take the ratio of the leading coefficients. So the leading coefficient up top, that's just 1. The leading coefficient down bottom is negative 1. So our horizontal asymptote is 1 divided by negative 1, which is just negative 1. So then we get this kind of grid, and then our only job left is to test. So we need to test to the right, to the left, and in between. So I'm going to test to the right first. So I'm going to plug in 4. When we do that, 4 squared plus 4, so that's 16 plus 4, that's 20. Negative x squared, so that's negative 16. Negative 16 plus 9 is negative 7. This is less than negative 1, so our graph is going to be down below. We're going to test to the left. We should get the same thing because we're just dealing with square. Actually, no, we won't. So negative 4 squared, that's 16 still. 16 minus 4, that's negative 20. Oh, maybe we do. Negative 4 squared, that's 16. Negative 16, negative 16 plus 9. Wait, hold on a second. Yeah, I did that wrong. Negative 4 squared, that's 16. 16 minus 4, that's 12. And then on the bottom, we get negative 16 plus 9, which is negative 7. This is smaller than negative 1, so our graph is going to be down below. And then we test in between, so we can test 0. So we get 0 over 9. That's above negative 1. So our graph is going to follow these asymptotes down up above. And then that's our graph. Number 10, same type of question, just different kind of conditions. Again, we're going to try and factor stuff out. So up top, we can take out an x. So we're left with x plus 4. On bottom, we can take out a negative 3x. We're left with x plus 2. Okay, so we can factor something out here, and that's the x's, right? So x equals 0 is a whole. And then for vertical asymptotes, we're going to take everything else, and set that equal to 0. So x equals negative 2 is a vertical asymptote. For horizontal, again, we compare the degree of the numerator and denominator. In this case, we have the same condition as above. I highly recommend that you look over those other conditions, right? When n is less than m, when n is greater than m, because I can tell you right now there is a slant on the test. So we get y is equal to negative 1/3. That's our horizontal. And then everything else is just testing again. So we can test to the right first, f of 0. When we do that, we get negative 2/3. Negative 2/3 is below 1/3, negative 1/3. So our graph is going to be down below. When we test to the left, negative 3 plus 4, that's 1. Negative 3 plus 2, that's negative 1, times negative 3 is 3. So we get positive 1/3. Positive 1/3 is above negative 1/3. So our graph is going to look like this. Okay. The only thing that we need to put in here now is the whole. And there's a hole at x equals 0. So we're going to put a little gap right at 0. And then that's done. Okay. So this is the difference that I kind of want you to see. When you factor something out, that thing factored out equaling 0, that's the whole. That's just the x part of where the hole is. When you draw your graph, after that, you put your hole in. Okay. There are 3 conditions, which I'll write down just because you didn't see them on this, for horizontal. Guess I'll do it in orange because that would make sense. Okay, if n is less than m, so the degree of the numerator is less than the degree of the denominator, y equals 0 is your horizontal asymptote. If n is equal to m, so the degrees are equal, you get the ratio of the leading coefficients, which you've seen twice on this. If n is greater than m, you need to check for a slant. In order to check for a slant, you try and divide the denominator into the numerator, so you're doing long division like we did right here, right? So this would be the denominator. This stuff in here would be the numerator, and you're trying to divide out. Everything matters except the remainder, and then that's going to be your equation of the line. How do you know where to graph the hole? We know where to graph the hole because these x's canceled out. So when we set those equal to 0, that's like, that is still, right? These x's are still in this equation. So if we set that equal to 0, that's where that hole is going to be. So whatever you factor out, when you set that equal to 0, that's where your hole is going to be. So if we factored x minus 7 over x minus 7, if we factor that out, the hole would be at x equals 7. Right? So if we got something that looked like 4x times x minus 7 times x plus 3 over x minus 7 times 3x minus 2. Okay, these x minus 7s would cancel, and we'd have a hole at x minus 7 is equal to 0, so x is equal to 7. So whatever you factor out and set that equal to 0, that's what the hole is going to be. This is just an example. I just made that up off the top of my head just now, so don't panic if you don't know where that's from. I just made it up. Okay. So that's the asymptote questions. The rest is just logs, which should be relatively easy. Okay. I'm going to let you go back to the video. I made 3 of them that go through the properties and stuff. If you want to like just screenshot those and have those in front of you. We also went over them in class. I'll kind of write out some as we go and talk about them. Right. But for solving each equation, when we have 2 logs on the same side, we want to combine them as much as we can. When we have the difference of 2 of the same log, we're going to take the quotient of the inside. So this goes to the natural log of x plus 6 over x. Right? We have the difference of this thing. If this were the product, we'd be multiplying them together, but because it's the difference, we're dividing them. Think properties of exponents. When we are, how do I want to put this? When we are dividing 2 bases, we're subtracting their exponents, right? So this is like the divide part. This is like the subtract part. They're both the same thing. Okay. And then on the right, we're just left with 4. Okay. Now we need to get rid of the natural log. So in order to solve for x, we need to get rid of that natural log. In order to do that, right, the base of ln is e. So we're going to take everything as an exponent of e. What we do to one side, we have to do to the other. Where do you find the y value for the plot? You're talking about the asymptote question. I'm not worried about where the y value is. I just want you to know that there's a hole at x equals 0. Okay, so just know it's on x equals 0. Don't worry about where it is on the y. All right, when we take e to the power of ln of anything, the e to the power of ln cancels, so we're left with x plus 6 over x is equal to e to the 4th. In order to solve this, I'm going to come back up here. We'd multiply both sides by x, so we'd get x plus 6 is equal to x times e to the 4th. I would subtract x from both sides now. So we get 6 is equal to x e to the 4th minus x. We can factor out an x. And then divide by that e to the 4th minus 1. So our answer would be this. If you want to get a decimal for that, be my guest, but this is what I'm looking for. Number 12 is similar, except it's not natural log, it's just a different base, okay? So we see 2 logs on the same side, so we need to combine them. So when we combine them, we're going to have log 5 of x times x plus 4, which is x squared plus 4x. In order to get rid of the log base 5, we're going to take everything as an exponent of 5. And what we do to the left-hand side, we also have to do on the right-hand side. So we have 5 to the first on the right. 5 to the power of log 5 cancels. So we have x squared plus 4x is equal to 5. Well, now this is just a quadratic, which you should know how to solve. If we subtract the 5 over, we get x squared plus 4x minus 5 is equal to 0. Now we have a quadratic that we actually can solve. Okay, so we could factor. We could use the quadratic formula. I'm going to factor. Let's see, plus 5 minus 1. So then x is equal to negative 5, and x is equal to 1. On 13, you can do this using logs if you want to, but you don't actually need to. I see a common base on both sides, so 5 to the power of something. So I can rewrite 25 as 5 squared. That's being taken to the power of 3 minus 3x. 125 is 5 cubed. So this is 5 to the power of 6 minus 6x is equal to 5 cubed. We can use the 1-to-1 property. We can get rid of the 5's. So 6 minus 6x is equal to 3. And then we're just solving this, okay? So subtract x, 6 from both sides. You get negative 6x is equal to negative 3. Yeah. So x is just equal to 1/2. That's only if you have a common base on both sides. Okay. 14, we actually do need logs. All right. So the way, yeah, well, I don't think we need to go through that. So I have to add 8 to both sides. So we get 20 to the power of 10x is equal to 91, 92. Yeah, no. Yep, 91. In order to cancel out the 20, the base of 20, we have to take the log base of 20 on both sides. What I see a lot of is people canceling the logs on both sides. You cannot do that. You can only cancel the log on the left side because that has a log base 20 of 20. So then we're left with 10x. Let's equal to log base 20 of 91. And then we divide both sides by 20 or by 10, and we're done. If you do not know how to do that type of problem, think about operations on x. The very first thing that happens to x in this problem is multiply by 10. Okay, 10x is being taken as a power of 20, so exponent of 20. And then that 20 to the power of 10x, we're subtracting 8 from it. So in order to solve, what we need to do, that should be sub, not sub. So in order to solve, what we need to do is we need to add 8, so x plus 8. We need to do the inverse of exponential of 20, so log base 20. I guess it shouldn't be x, it should be 83. So 83 plus 8. And then we divide by 10. Okay, so we're listing operations on X. We're inverting the operation and reversing the order. Then if you do that, that gives you the directions to solve for X. Okay. Same thing for number 15. 15 is a little bit simpler. 15 says we're going to divide by 3 on both sides. We have to cancel out the base of 15, so we're going to take log base 15 on both. The log base 15 of 15, that cancels, so we have negative 5n is equal to log base 15 of 91 divided by 3. Again, we cannot cancel the log on the right because they do not have the same base on the inside and the outside. And then we're just taking everything and dividing it by negative 5. So we get n is equal to log base 15 of 91 divided by 3, all divided by negative 5. And that'll be our answer. You can also take this, get a number, and plug it back in and see if it works. Number 16 and 17, I'm giving you this exact same problem on the test. You've had this for like the last week or so. I'm going to let you do this on your own. I'm not going to show you how to do it, okay? It's very similar to this stuff up here. There's just a couple more steps, okay? So that is the entire test. I'm going to leave this open for a couple minutes, make sure there's no questions. So I'm going to slow scroll through it again, and as you have questions, please ask. It doesn't have to be about the questions that are currently on the screen. Just I need questions to answer. I'm just going to scroll through until I have any. What percentage of our grade is this final worth? It's worth 20%. So a fifth. But anyway, I'm going to mute myself and I'll scroll down. Actually, I can at least give you like a kind of a breakdown of what scores are going to be because I've graded these before. Number 1, I think, is 7. Actually, let me get my iPad before I do that. So these won't be exact, but they'll at least give you a good idea. Yeah, so number 1 is going to be worth 7 no matter what. I know that for a fact. Number 2, the line equation, that's going to be worth 4. The transformation problems, are each going to be worth 4. So 4 apiece, so 16. Uh, 7, the graphing one. Okay, so the last one was worth 7. No, the last one was worth 9. But it's probably going to be like a point or two more, so I'm thinking 11. Because there's a little bit more to it. Number 8. That's 5 to 8, probably 6. Let's see. Yeah, 6. 6 works. again, this isn't exact. I'm going to go through this a little bit more, but I can at least give you a good idea about what each of these are worth. Number 9 and 11, I believe they were worth 4 to 5, depending on which type of problem it is. So 4 to 5 for each of these, so 8 to 10. And then the log questions, this is just by steps, right? So anywhere between 3 and like 5. So about 15 to 20 points probably. 15 to 25. And then the last problem is probably going to be worth like 8 points, 4 per part. What are horizontal asymptotes on number 10? The horizontal asymptote is negative 1/3. The degree of the numerator is 2, the degree of the denominator is 2. Those things are equals, which tells us to take the ratio of the leading coefficients. The leading coefficient up top is 1. The leading coefficient on bottom is negative 3. So 1 divided by negative 3 is our horizontal asymptote. Okay. So I'm going to leave this open for a minute, keeping in mind that I did not do this problem. I'm going to let you guys do that because I'm giving you the exact same thing on the test and I'm asking you to show work. Okay. So I'm going to leave this open for the next probably minute. And if there's no questions by then, I'll shut it down. And I'll see you guys tomorrow. Okay. So if you have questions, this is your last chance. And we'll go from there. Okay. It doesn't seem like anyone has questions, so I'm going to shut this down. Thank you if you watched. I hope you got something out of it at least. Keep in mind there's 2 versions of this on campus. There's the original one that I gave you. Okay. I have the answer key uploaded to on campus. And then there's this one that I just did. So this is the second version of this practice test. There's a first one and the answer key in on campus. You only are able to do these if you're able to do these on your own. So either maybe rewind, try and do a couple of these on your own without any help. If you're able to do that, you're in a really good spot. If you're not, then I would continue to work through a couple of these. What I don't recommend you doing is staying up super, super late to study for this because that's just not a good thing to do. Just make sure you're able to do the stuff on the test. Do the things that you know how to do first, and then get to the ones that are a little bit longer or a little bit harder. All right. If you have questions, email me. I'll try and answer them. What am I forgetting? I think that's it. Okay. So thank you. And I'll see you guys tomorrow. Good luck.